In this lesson, we're going to determine the distance between 2 points when one of them isn't the origin. So let's take, for example, this question. Determining the distance between the points A, 5, -4, and B, -7, 1. Well, if we were to think about it, what we're really asking for is the distance, is the length of that green line. There's the point B, and there's the point A, and we'd like to know the distance of that line. And we see that we could make a right-angled triangle if we go down 5 units and to the right 12 units. We would have a right-angled triangle because vertical lines meet horizontal lines at a 90-degree angle. And because of that, we would be able to use the Pythagorean Theorem. In other words, we'd be able to say that the horizontal distance is 12 and the vertical distance is 5. And since the horizontal dimension and the vertical dimension are perpendicular, we can use the Pythagorean Theorem. Okay, so we do that. We say that d squared is equal to 12 squared plus 5 squared, which is 144 plus 25, which is 169. So d is the square root of 169, which means d is 13. And so that means that the distance between the 2 points in question is 13 units. Okay? But if you look back at the equation we had, we could have put negative numbers in here. We could have put negative values in for the distances under the square root because we ultimately square those values. So in other words, if I was to say that d squared was -12 quantity squared, I would have gotten 144 because -12 times -12 is 144. If I let it be 12, I still get 144. Same with y. I could have put a negative value in here. I could have called that -5, and I still would have gotten positive 25 as my answer. And so in other words, this number here inside the bracket could be negative or positive. And so we see that we could do that, and ultimately, since we're squaring those values, we don't ruin our answer. And so because of that property, we can see that we can subtract the x2 minus x1, and whether it's positive or negative won't matter because we're going to ultimately be squaring it. And similarly, we can evaluate y2 minus y1, and whether it's positive or negative ultimately won't matter since we're squaring our result. And so we can develop a formula for the distance between 2 points, which is that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So let's do a few examples here together. We're going to find the length of the line segment between the points A, -1, 0, and B, 5, 2. Well, we use our formula, and we sub in x2 minus x1 and y2 minus y1. And that gives us the square root of 36 plus 4, which equals the square root of 40, which when we simplify becomes 2 root 10. For our next question, we can figure out the distance between the points G, -7, 8, and H, -7, -5. Well, x2 minus x1 is 0, and y2 minus y1 is -13. So we square 0 and we square -13, and then we take the square root of the sum. So we get the square root of 0 plus 169, which ultimately equals 13. So the distance between those 2 points is 13. The distance between the points -4, 7 and 3, 1 is evaluated in a similar way. 3 minus -4, quantity squared, plus 1 minus 7, quantity squared, and then the result is square rooted. and we get the square root of 49 plus 36, which equals root 85. Okay, for our next example, we're going to see we have a triangle with vertices at A, B, and C, and we want to determine the perimeter of the triangle and show that it's an isosceles triangle. So one thing we can do is graph the points. A, -1, -1 is down here. B, 2, 0 is right here. And C, 1, 3 is up here. And in order to get the perimeter, we should know the length of each side. So we begin with the distance between A and B. So x2 minus x1 squared plus y2 minus y1 squared, and the sum square rooted, equals root 10. The distance from A to C is x2 minus x1 squared plus y2 minus y1 squared, and the sum is square rooted. And what we end up with there is the square root of 20. And if we simplify that, we get 2 root 5. And finally, the length of the side BC is the square root of x2 minus x1 squared plus y2 minus y1 squared, and we get the square root of 10. And if you go back, you realize that the length of the side AB is equal to the length of the side BC, and therefore it's an isosceles triangle. And the perimeter is equal to the sum of the sides, root 10 plus 2 root 5 plus root 10. So when we get that, we simplify it a little bit to 2 root 10 plus 2 root 5. That's the perimeter of the triangle. Okay? Now, the next question is whether we have a right triangle. Well, one of the methods we can use to determine that is the slopes method. If we can show that two sides are perpendicular, then we have a right triangle. And the way we do that is to show that the slopes are negative reciprocals. So we can find the slope of the line segment from A to B. The slope of that line right there. And we do that by using y2 minus y1 over x2 minus x1. Well, 0 plus 1 over 2 plus 1 is 1 over 3. So the slope of side length AB is 1 over 3. And the slope of side length BC, using the same slopes formula but with the points B and C used instead, we get the slope of side length BC is negative 3. And since 1 over 3 and negative 3 are negative reciprocals of each other, we see that this side length right here is perpendicular to this side length right here, and therefore we have a right triangle. Okay? Well, another way of doing that is to use the Pythagorean method. We can determine that a triangle is a right triangle by using this Pythagorean method. And so the way it works is this. The Pythagorean theorem tells us that if we have a right triangle, then the hypotenuse squared is equal to the sum of the squares of the other two sides. Well, similarly, if we can show that the longest side squared is equal to the sum of the squares of the other two sides, it means we therefore have a right triangle. And so what we're going to do is test this Pythagorean theorem. We know that the longest side is 2 root 5, which is root 20. And so we're going to test to see whether root 20 quantity squared equals root 10 quantity squared plus root 10 quantity squared, because those were the side lengths of the two smaller sides. Well, root 20 quantity squared is 20, root 10 quantity squared is 10, and again root 10 quantity squared is 10. And since 20 equals 20, we see that we have c squared equals a squared plus b squared, which means we have a right triangle. Okay, so that's the Pythagorean method of showing that we have a right triangle. Now, for our next question, we're going to suppose that the triangle that we just were talking about was translated horizontally and vertically, so that A was on the x-axis and B was on the y-axis. And then we want to know what would be the coordinates of the image points that we obtained. Okay, so going back to our diagram, if we were to put A on the x-axis, we would see that we would have to go up 1 unit. And if we were to put B on the y-axis, we would see that we would have to go over 2 units. So in other words, we have to go up 1 unit and over 2 units in order to get A on the x-axis and B on the y-axis. Okay, so that's what we're going to do. Remember that. Up 1 unit and left 2 units. So our point A goes up 1 unit and our point B goes over 2 units. But since it's a triangle and it's a solid shape, all points have to do the same thing. So every point has to go up 1 unit and left 2 units. So if we go up 1 and left 2 for every single point, we see that what we're going to really end up doing is we're going to be adding 1 to each y coordinate, because that's how you translate up 1 unit, and we're going to be subtracting 2 from every x coordinate, because that's how you move to the left 2 units. So our new points are going to be the same as the coordinates of our old points, but with every y having 1 added to it, and every x coordinate having 2 subtracted from it. Okay? So since our original a was at -1, 1, we're going to add 1 to the y and subtract 2 from the x. So -1, -1 will become the image A prime, which is -1 minus 2 and -1 plus 1. Translate 2 to the left and translate up 1. Well, -1 minus 2 is the same as -3, and -1 plus 1 is the same as 0. The point B is at 2, 0. So we're going to translate that so that the image B prime is at 2 minus 2, because we're now subtracting 2 from every x, and our y coordinate will be at our original y value plus 1. This is what it means to translate 2 to the left, and this is what it means to translate 1 up. So 2 minus 2 is equal to 0, and 0 plus 1 is equal to 1. And that's how we got that point. And finally, our point C. Originally, C was at the point 1, 3. Okay? Originally, C was at the point 1, 3. Well, we're going to translate that over. And so 1, our x coordinate, we subtract 2 from it, and 3, our y coordinate, we add 1 to it. And we get the new point C prime, which is -1 and +4. Okay? And so notice that we took every original point, once we realized what the rule had to be, and we subtracted 2 from every x coordinate, and we added 1 to every y coordinate. Okay? And finally, we're going to take a look at the rectangle ABCD. This question is kind of cool because they don't actually tell us what the coordinates of point D are. We just have to figure it out ourselves. So we graph the points A, -4, 2, B, -4, 7, and C, 6, 7. And now we want to determine the coordinates of point D. Well, we have a vertical line on this side with x values of -4, so we're going to have a vertical line on this side, and since the x value of this point is 6, the x value of this point should also be 6. Similarly, on the top we have a horizontal line with y values of 7, so that means down below we should have a horizontal line with y values of 2, because the y value was determined by this point right here. So if we have the point 6, 2, it allows us to keep a vertical line on the right, and just like on the left, and if we have a y value of 2, then we are allowed to keep a horizontal line up the top and therefore also at the bottom to make it be a rectangle. The length of the first diagonal is 5√5 using our distance formula, And the length of our second diagonal is also 5 root 5 using our distance formula.